Okay, today we're talking about absolute value inequalities. So we're actually going to combine what we learned on compound inequalities and absolute value equations. So we're adding in our date, page number, title, learning target, and making sure we put that in our table of contents. So what we're doing is we're saying, okay, the distance from 0 this time is less than 8. So, okay, let's start with what two numbers are 8 away. -8 and +8. If the distance from 0 is smaller than 8, it can't actually be -8 or +8 because those are exactly 8 away. So I'm going to talk about the things that are smaller than 8 away from 0. Well, 6 is smaller than 8 away from 0. So is 4. So is 2. So it's actually going to be everything in between here, because even like 6.5 right here is smaller than the distance from 8 to 0. Okay, so 8 units away from 0. So it's everything in between these two numbers. Okay, so for example, this 9 out here, right here, is more than 8 away from 0, so it's not included in my solution. So I'm not graphing that part. So this looks like our compound inequalities, like our and statements. It's everything in between here. Even -10 out here, this is more than 8 units away. It's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 units away from 0, so that's why it's not included. Okay, so this should remind you of your and statement when we did the stuff that was shaded by both for compound inequalities. Okay, so I want you to pause and write this next slide down. If it's less than or equal to, which should make sense, absolute value of x, let's say that this is less than or equal to 2 from 0. If that's the case, then if I was to graph that, I would start here at 0. This is 1, 2, -1, -2. Okay, well, what two numbers are exactly 2 away from 0? Well, that would be 2 and -2. And since that's or equal to, it could also be 2 or -2 units away from 0. Well, this says the distance of x is not only equal to 2, but it's also smaller than that. So 1 would be included, 1.5, -1/2, all those things between 2 and -2 would be included as well. And that was an and statement. So here's what it would look like if it was absolute value of x is greater than 2. So the distance from 0 is bigger than 2. If I was to graph that on a number line, there's 2, well, -1, -2, -3. The two numbers that are exactly 2 units away from 0 are 2 and -2. But the distance away from 0 can't actually be 2 because it says that it's bigger. So it's everything that's bigger than that. So like 2.5, 3, 4, 5. Everything this way is more than 2 units away from 0. I count 1, 2, and then everything bigger than that would be included. Same thing here. So I would count 1, 2 units away, but like -2.5 is bigger than 2 units away. So is 3, -3, -4, -5, everything out this way. So that should remind you of our or statements. It has to satisfy either or. So let's talk about how to solve them. First of all, I know this is going to be an and statement when I'm done, which means I should shade in between my two numbers. But what I'm saying is that what's inside here, this x minus 4, has to be smaller than 3 units away. So I'm still going to use x minus 4 both times, but this one can be smaller than 3 or bigger than -3. So remember when we divided by a negative number, when you flip this sign, it's the same thing. Notice that this sign changes as well. So when I make this the positive, this all stays the same. And then when I go to my negative equation, the sign flips and I change it to a negative. Alright, so now I'm going to solve for x. I'm trying to get x by itself, so I'm going to add 4, and x. This is 7. And I didn't multiply or divide by a negative, so my sign stays the same. So if I was to graph this part, I would say x is smaller than 7. So I would put an open circle at 7, and I would start going this way. For this one, I would try to get x by itself, so I'm going to add 4, add 4. This goes to 0, I'm left with x. This goes to 1, because negative 3 plus 4 is 1. And I didn't multiply or divide by negative, so it's still greater than. That has not changed. So I'm going to have an open circle at 1, because it can't be equal to 1, and it's going to be everything bigger than that. So my inequality would look like this to show that it's everything in between those two numbers. And then if I was to write it in interval notation, I would say the lowest number it is 1, and it's a parenthesis because it can't be 1, and it goes from 1 to 7 with a parenthesis. That's interval notation. Example 2, same thing. What's inside here has to be bigger than or equal to the distance from 0 of 9. So notice that this is going to be bigger than the distance, so this is going to be an OR statement. The first one, the positive one, stays the same. The negative one, you're going to flip this to make it less than or equal to, and now it's going to be a negative 9. Alright, so we're going to graph them. Or, I'm sorry, solve them. Get x by itself, subtract 1, subtract 1. 2x is greater than or equal to 8. Divide both sides by 2. X is greater than or equal to 4. So if I was to graph that, it would be a closed circle at 4, and it would be going to the right because it's everything bigger than 4. For the other one, box 2x minus 1, minus 1, this gets more negative, it's negative 10. 2x, divide both sides by 2. X is less than or equal to negative 5. So I would have a closed circle at negative 5. And I would shade everything to the left of it because it's everything smaller than negative 5. And this graph is correct because look, we said in the beginning it should be an OR statement. Last one. If you remember back from when we did absolute value equations, this had to be by itself before I could start here. So in order to make that happen, I'm going to start by adding 1. So before I can see how far away it is from 0, I have to have this by itself. Alright, so I'm going to break it apart into my two different equations. The first one, x plus 2 is the normal one, where everything stays the same. This one, x plus 2, becomes less than negative 8. And now I'm going to solve them. Minus 2, x is greater than 6. Minus 2, x is less than negative 10. So I'm going to graph them. Starting with this one, x is bigger than 6. Open circle at 6, and I'm going to the right because it's everything bigger than 6. This one, I'm starting at negative 10, and it's an open circle, and I'm going to the left because it's everything bigger than negative 10.